Hi, my name is Patrick Reagan. Welcome to the Operational Procedures series of videos where we discuss backup and restore methods, ticket systems, documentation, and change management. In Part 1, Backup and Restore Methods discusses the importance of backups, different types of backups, how frequent you should backup, different backup media, 3-2-1 backup rule, and grandfather father-son rotation. For those who are going to take the A+ exam, there are practice questions at the end of the video. If you have not already, subscribe to the Pat Has Your Back channel. Data stored on a computer or stored on the network is vital to the users and probably the organization. It represents hours of work and its data is sometimes irreplaceable. No matter how much effort, hardware, and software you put into a system, you eventually have failure. Sometimes when the downtime occurs, you may have data loss. A backup, or the process of backing up, refers to making copies of data so that these additional copies may be used to restore the original after data loss event, system failure, or outage. They can be used to restore entire systems following disaster or to restore a small set of files that were accidentally deleted or corrupted. Question: what is the best method of data recovery? Answer: backup, backup, backup. When planning your backups, you need to ask, what are you going to back up? Where are you going to store the backups? How often are you going to perform the backups? How are you going to perform the backups? How long will it take to perform the backup? How long will it take to perform a restore? Remember, when you have problems, it is often too late to do a backup. Therefore, you need to plan ahead and perform backups regularly. When a novice thinks of backups, he or she will most likely think of backing up data files such as Microsoft Word or Excel documents. However, they're more than just data files. You have the program files that make a computer do what it needs to do. You also have mailboxes, email databases, SQL databases, and other data types that may need special software to read and back up. In addition, when determining what and how often to do backups, you should also look at the time it would take to reinstall, reconfigure, or recover the item. Program files usually do not change, and so they do not have to be backed up as often as data. Data files change often, so they should be backed up much more often. The Windows system state is a collection of system components that are not contained in a simple file that can be backed up easily. It includes the boot files, the system registry settings, the system protected files or SPF, which are the critical files needed to run Windows, the Active Directory files if it is the domain controller, the shared system volume or sysvol, and the CompTIA class registration database. Windows Backup and most commercial backup software packages will back up the Windows system state. If you want to perform a complete restore of a system running Windows, you will need to back up all files on the drive and the system state. The types of backups each vary on the time it takes to do a backup and restore. Traditional backups include full backup with incremental backups, and full backup with differential backup. Full backups back up all files and data that have been designated. For files, it will shut off an archive attribute bit to indicate that the file has been backed up. The archive attribute is an attribute that is used to indicate if a file is new or changed and it has not been backed up. For example, you will do a full backup once a day, once a week, or once a month, depending on the importance of the data and how often it changes. To perform a restore from full backup, you just need to grab the last full backup. A full backup offers the fastest restore. Full backups consume the most space and the slowest backups. Full backups with incremental backups starts up with a full backup followed by several incremental backups. For example, once a week you'll perform a full backup on Friday night, which will shut off the archive attribute indicating that the files were backed up. then any new files or change files will have the archive attribute turned on. You will then perform an incremental backup Monday, Tuesday, Wednesday, and Thursday night, which will only back up new and changed files and shut off the archive attribute. When you do restore, restore the last full backup, and then restore each incremental backup from the oldest to the newest. Full backups with incremental backups offers the fastest backup, but offers the slowest restore. Full backups with differential backup starts with the full backup followed by several differential backups. For example, once a week you'll perform a full backup on Friday night, which will shut off the archive attribute indicating that the files were backed up. Then any new files or change files will have the archive attribute turned on. You'll then perform a differential backup Monday, Tuesday, Wednesday, and Thursday night, which will only back up new and changed files since the last full backup, but will not turn off the archive attribute. Since the archive attribute was not turned off, when you do subsequent backups, it will back up the new and changed files again. When you do a restore, restore the last full backup and the last differential backup. Another backup type that is available from some backup software packages, including Microsoft's backup software, is the copy backup. A copy backup backs up the designated files but does not shut off the archive attribute. This is used for impromptu backups such as before you make a system or application change. Since it does not modify the archive attribute, it will not interfere with your normal backup schedules. A synthetic backup is a type of backup strategy that combines elements of full and incremental backups to create a synthetic full backup without the need to perform a traditional full backup operation. It involves using a combination of full backups and subsequent incremental backups to merge and create a new updated full backup image referred to as a synthetic full backup. A synthetic backup reduces the backup window and bandwidth used since it only has to perform incremental backups and allows faster recovery time since the synthetic backup will have all files. The backup device or mechanism that is creating the synthetic backup will need to do additional work to create the synthetic full backup. The frequency of backups should be determined by how important the data is. What is the most amount of data that you can lose if a failure occurs? If you back up every night, you could lose up to a day of work. How often does the data change? The choice of backup media depends on various factors, including data volume, retention requirements, budget constraints, and disaster recovery considerations. Hard disk-based storage offers high capacity, fast read-write speeds, and affordability, making them suitable for storing large volumes of backup data. Solid-state drives, or SSDs, provide faster performance, lower power consumption, and greater durability compared to HDDs. While they typically have lower capacity and higher cost per gigabyte, SSDs are well suited for storing critical backup data that requires fast access times and reliability. Network-attached storage, or NAS, devices offer centralized storage and file sharing capabilities for backup and archival purposes. They provide scalability, fault tolerance, and data redundancy features such as RAID configurations. NAS solutions are ideal for organizations with distributed data environments or remote offices. Magnetic tape drives offer high-capacity storage, long-term archival capabilities, and cost-effectiveness for large-scale backup environments. They are suitable for storing backup data that requires offline, off-site, or long-term retention. Tape libraries provide automated backup and retrieval workflows for managing large tape collections efficiently. Cloud storage services such as Amazon S3, Microsoft Azure Blob Storage, and Google Cloud Storage offer scalable, flexible, and cost-effective options for storing backup data in the cloud. They provide built-in redundancy, durability, and geo-replication features, ensuring data availability and resilience against hardware failures and site-wide disasters. CDs, DVDs, and Blu-ray discs or optical disks provide portable, low-cost storage options for small-scale backups or archival purposes. They offer write once, read many, worm capabilities, making them suitable for storing mutable data or compliance archives. However, optical medias have limited capacity and slower read-write speeds compared to disk-based or tape-based storage solutions. When you plan a backup, your plan needs to balance between accessibility, security, and cost. Larger organizations will often combine one of the following management methods. Online storage is the most accessible type of data storage, usually using hard disk or disk arrays. Restore can begin in milliseconds, but it can be relatively expensive. In addition, online storage can be easily deleted or overwritten by accident or intentional action. Nearline storage is typically less accessible and less expensive than online storage, usually consisting of a tape library with the restore time beginning with seconds or minutes. Offline storage requires some direct human action to physically load tapes into the tape library or drive. Access time can vary from minutes to hours or even days if you have to order tapes from an off-site storage area. In the event of a disaster, you can switch to the backup site or DR site while you fix or repair the primary site. Unfortunately, this method is the most expensive solution and the most difficult to implement properly. Backups can be stored on-site or off-site, which on-site backups don't require internet link or delivery service. Data is immediately available and is generally less expensive than off-site. Off-site backups are stored away from the site, and transfer data over internet or WAN links or pickup service is needed. Data is available after a site disaster. Restoration can be performed from anywhere, but is usually slower or have delays when compared to on-site backups. Organizations often use both. Do not store backups on the same machine that has data that you're trying to protect. If you're in a region that is known for natural disasters, such as hurricanes, tornadoes, or earthquakes, you should consider regional diverse backups, which store backups in multiple geographical regions in case your site and region faces one of these natural disasters. Even if you are in a region that is not known for regional disasters, you should consider storing at least one copy in a different region. The 3-2-1 backup rule is a widely recommended best practice for data protection and disaster recovery. It provides a simple and effective strategy for ensuring data availability, integrity, and recoverability by emphasizing redundancy, diversity, and offsite storage. The rule is typically expressed as follows. Keep at least 3 copies of your data. This means maintaining 3 separate copies of your data to guard against data loss. These copies should include the original data plus 2 additional backups stored on different devices or storage media. Store the copies on 2 different types of media. Storing backup copies on multiple types of storage media helps mitigate the risk of data loss due to hardware failure, media corruption, or other storage-related issues. For example, you can use a combination of disk-based storage and tape-based storage for added redundancy. Keep 1 copy off-site. Storing at least 1 backup copy off-site ensures that your data remains protected in the event of a site-wide disaster such as a fire, flood, theft, or other catastrophic events. Off-site backups can be stored in remote data centers, cloud storage services, or secure off-site locations. Another consideration you should keep in mind is that backups do fail from time to time. You should always keep multiple backups. If a backup failed, you can go back to the previous backup. You should periodically test your backups by doing a restore to make sure that the backup is working and that you're backing up the necessary files. Second, you should have some type of rotation. When you restore your backup, you're making sure that your backup is good, but you also need to test your recovery procedures to make sure that you know what to do when you have to restore from backup. One common backup rotation scheme is the grandfather, father, son, or GFS. The son backup is done once a day, and those backups are rotated on a daily backup basis. For example, you may keep the son backups for 30 days. At the end of the week, the daily backup is promoted to a weekly backup. For example, you may keep the father backup for 90 days. The weekly or father backups are rotated on a weekly basis with one graduating to grandfather status each month, such as the first Friday of the month. For example, you may keep the grandfather backup for a year. This monthly backups would traditionally be stored off-site. Of course, this is based on the needs of what needs to be sent off-site. Windows 11 has two mechanisms for backups: Windows Backup and Control Panel's Backup and Restore Windows 7. Windows 11 doesn't include a dedicated Windows Backup tool. Unfortunately, the Windows Backup tool is very limited on where you store the backup to the cloud, such as your OneDrive account. It will back up your folders, apps, settings, and credentials. One advantage is that you can restore to any other machine running Windows 11. If you want to use the built-in Windows tool that allows you to specify what to back up and where to store the backups, you can use the Control Panel's Backup and Restore Windows 7. You can select which folders to back up, schedule backups, and create a system image of drives. In an enterprise environment, I would recommend a third-party backup tool which will have more options. Question: You're upgrading the backup system for documents at a law firm. The current backup system fills up with 3 full backups. If you're not concerned with restore time, how can you retain more versions? Answer: incremental. Question: You're in a region that is known for earthquakes. Which of the following would you recommend? Answer: regional diverse backups. Question: You're worried about ransomware. Which type of backups would you use if you only have a few files that are modified regularly and you have limited storage space? Answer: perform a differential backup. Question: Which type of backup allows for the fastest restore? Answer: full. Question: You just installed a new backup system. Which type of backup should you perform first? Answer: full. Question: Which type of backup will minimize network traffic? Answer: synthetic. Question: Which type of backups requires up to 2 restores? Answer: differential. Question: Which backup method would you use if you only can have 2 sets of tapes to restore? Answer: full. This question is a little bit tricky. You should use full backups because you should have no more than just one backup copy of data in case the backup fails or is corrupted. Question: in the grandfather, father, son rotation, which backup do you keep the longest? Answer: grandfather. For more information, visit these sites. In summary, data stored on a computer or stored on the network is vital to the users and probably the organization. A backup, or the process of backing up, refers to making copies of data so that these additional copies may be used to restore the original after data loss event, system failure, or outage. Backup is the best method of data recovery. Windows System State is a collection of system components that are not contained in a simple file that can be backed up easily, including boot files, registry, and sysvol. The type of backups each vary on the time it takes to do a backup and restore. The additional backups include full backup with incremental backups, and full backup with differential backup. A synthetic backup is the type of backup strategy that combines elements of full and incremental backups to create a synthetic full backup without the need to perform a traditional full backup operation. When you plan a backup, your plan needs to balance between accessibility, security, and cost. Do not store backups on the same machine that has the data that you're trying to protect. The 3-2-1 backup rule is a widely recommended best practice for data protection and disaster recovery. Thank you for watching this video. The next video will be Operational Procedures, Part 2, Documentation, Org Resources, and Change Management. If you have not already, don't forget to subscribe to the Pat Has Your Back channel. Thank you.